Hello everyone, you are highly welcome. In today's class today, we are going to be looking at how to form differential equation given a function. So now, looking at this, the question said obtain the differential equation given the function y equals x plus a over x. So before we move on, so let me tell you what to do whenever you are asked to form or to obtain a differential equation if you are given a particular equation of function of y. So now what you need to do, your point is to make sure we eliminate all the constant, arbitrary constant that is in the question. Like this one, the arbitrary constant that is here is a. So we find means of eliminating it. All right, then also we find means of differentiating the function we are given. The y, you differentiate it. Now, how many times are you differentiating? If you have two arbitrary constants, if you have one arbitrary constant, you are going to differentiate the function one time. If you have two arbitrary constants, you are going to differentiate it two times. So this explanation is very, very important. So that's why I'm saying this. I don't want just to solve the problem and go like that. Okay, you should actually understand what we are trying to do. So now, in order not to waste much of our time, we have y equals x plus a all over x. That is the equation given to us. So we can label this equation one. So you know that from this equation one, we can actually make a the subject of formula. Okay. So now we can try to make a the subject of formula here. We try to multiply through by x. We don't have xy equals this will be x squared, and we don't have a here. So automatically, you can see that this implies that a is equal to xy minus what? X squared. All right. So which implies that here a can be, we can factorize x out. We don't have x into y minus x, because x times y we have this, x times x we don't have minus x squared. Are you getting it? So from there, so let's label this to be equation 2 because we are going to use it. Now, so from 1, now let's differentiate y. Okay, this is function 1. Let's differentiate it. Differentiate with respect to what? With respect to x. We can rewrite this equation 1 like y equals x plus a x to the power of minus 1. All right. So from the law of indices, we have dy dx now is going to be 1 plus, if you differentiate x, you're going to have 1. If you differentiate this, you're going to be minus, a x to the power of minus 2, because you need to take away, 1 from here. So we're going to have dy dx is going to be 1 plus. So now this plus will affect this, we have minus a x squared. But we can take it back to be x squared, right? Now from there, the next thing we're going to do, from there is that since we have dy dx there, so we're going to have dy dx, okay, equals, we are still having the arbitrary constant, which is a here, 1 minus, what is my a according to what I have here? A is what? A is x, a is what? A is x into bracket y minus x, okay, then divided by x squared. Are you getting it now? So from there, you can see that we have dy dx to be equals 1 minus, now x into y minus x, and this x can be splitted, multiplied by x. So where 1 will affect this one, we cancel out this one. We have dy dx equals 1 minus. All right. So from here, we're going to have y minus x, okay, over x. Now try to write this in a single fraction. So we're going to write this as over 1, okay. The LCM, multiply this and this together, we're going to have what? We're going to have x, okay. 1 x times x, we're going to have x minus y. You have to put the bracket here, minus x. So from here we have dy dx to be equals, we have x, using this to open the bracket, we have minus y, minus minus, we have plus x all over what? All over x. So now to round everything up, we're going to have dy dx to be x plus x. We're going to have 2x minus y, then all over what? All over x. So you can see that we have what we have a differential equation because we have dy over dx. Do you understand? So now from here we can see that we have eliminated the arbitrary constant. So at the end of everything now, so we have what we have, the differential equation we are asked to obtain, and this is this. So now please, if you enjoyed this class, kindly share, like, a comment, then follow our Facebook page for more exciting videos. Thank you so much. Bye bye.